So today we're going to be doing a bit of a walkthrough of some vector questions for Core Pure. So this is looking at AS and A level, seeing as they're covered in mainly the Core Pure 1 book, which is the AS book, but obviously it's applicable for book 2. Everything in this book you need to know for book 2. Okay, so there's going to be a mixed questions in here, some are a little bit trickier than others, but overall just a bit of good practice for Core Pure. Okay, so let's jump straight into the first question. So all these questions have been taken from the Core Pure 1 book. So I'll put the exercise here. So this is the mixed exercise question for from the chapter which contains vectors. So it's the very final chapter. So this is question 4, and it's an exam with problem solving. And basically what we've got here, so if I just get my pen, what we've got here now is a straight line L, which has the vector equation r equals 3 minus 2 1, and then lambda lots of 2 1 minus 1. Okay, so that's my position vector, the 3 minus 2 and 1, and then this is my direction vector below. So part A just wants us to write down a Cartesian equation for L. Now I've put this here. Now this is from your formula book, you don't have to memorise any of this, but it's from your formula book just to help. So hopefully you can see here. So what it's saying is that the position vector is the part of the numerator, and the direction vector B gives you the denominator. So if it helps, I will put it in that form, just to make it clear for people. So it's A1I, which would be 3I here, plus A2, which would be minus 2j, and then finally plus A3, so that's plus k, plus 1 lot of k. So that's my A. My B, my direction vector here, is going to be 2I plus j minus k. Okay, just using my direction vector in front of lambda, or behind lambda. So that's my A, that's my B. Now what we've got to do is get it into this form here, so that's going to be x. So we do minus A1, where A1 is 3, so minus 3, over B1, where this is my B1 here, this is 2. This is going to be equal to y minus minus 2, so plus 2, all over B2, which is just 1. And then finally it's going to be z. This is k, so it's going to be minus 1, all over minus 1. Okay, so that is simply just L. So L is equal to the x minus 3 over 2, which is equal to y plus 2 over 1, which is equal to z minus 1 over minus 1. Okay, so that's the first 2 marks done. So that's 2 marks done. Part B asks us that given that the point 0, A, B lies on L, can we find the value of A and the value of B? So 3 marks for this. Now it's a bit of a, it's not really too tricky. All you've got to do is consider this point they've given us. So 0, A, B. Well, if it lies on L, that means we can substitute it into L. So 0 minus 3 over 2 is equal to y plus 2, where y is A, so A plus 2 over 1. And then finally z, where z is B, so B minus 1 over minus 1. Okay, so, well, we can simplify this first part here. This would be minus 3 over 2. So what we've got here is A plus 2 over 1 is equal to B minus 1 over minus 1, which is equal to minus 3 over 2. So we can treat these separately now. So what I've got is A plus 2 over 1 is equal to minus 3 over 2. So in other words, I've got A plus 2 is equal to minus 3 over 2. Okay. And I've also got B minus 1 divided by minus 1, so that would be the same as 1 plus B, 1 minus B. So can I just rub that out? Eraser, yeah. So that'd be 1 minus B. So 1 minus B is equal to minus 3 over 2. Now all we've got to do is solve each one individually. So A plus 2 is equal to minus 3 over 2. So all I've got to do is subtract 2 off both sides. So therefore, A is equal to minus 3 over 2 minus 2. So that'd be minus 3 over 2 minus 4 over 2. And if you do that, you'd get minus 7 over 2 for A. And do the same here for B. So if I do it up here for B, well, that'd be the same as taking the B across here and then adding 3 over 2 to both sides. So B would be equal to 1 plus 3 over 2. And this one here would be 2 over 2. So that'd give me 5 over 2. And there we have it. So that's both A and B, where A is equal to minus 7 over 2 and then B is equal to 5 over 2. And that's all 5 marks for that question. So let's move on to the next one now. So this is from the exam paper 1, so this is right at the end of the Core Pure 1 book. And what it is we've got 2 lines, L1 and L2, and we've just got to show that the lines L1 and L2 do not meet. Okay, So for these questions, what you've got to do is consider each line and the components for each line and make it equal to the next line. So we've got to make minus 3i, so I just call it minus 3, plus 5 lots of lambda, so plus 5 lots of lambda. Well, that's got to be equal now to the other corresponding part of L2. So that's got to be equal to 10 plus 6 lots of mu, or plus 6 mu. Okay, do the same again. Well, we've got no j components, so that's just going to be 0 minus 1 lambda, so minus lambda. That's going to be equal, and do the same with L2 now, the corresponding parts, that's minus 1 minus 2 mu. And then finally, we've got 15k here, we've got 5k here, so that's going to be 5 plus 1 lot of lambda, because it's plus k times lambda, so plus lambda. That's going to be equal to 15 plus 4 mu. Okay, so we've got all our correct components matching now. Now we need to solve for mu and lambda, because what we're going to do is we're going to get two values, one for mu, one for lambda, and then we've got to sub it into the third equation that we haven't used. And what we should find, given that they don't meet, is we should get a contradiction. We should get something like, I don't know, 20 is equal to 17, something that clearly doesn't work. So let's do that. Well, the easiest bit to work with here is the minus lambda. Okay, so minus lambda is equal to minus 1 minus 2 mu. Just divide through by minus 1, I'd get lambda is equal to 1 plus 2 mu. Okay, so I've got lambda now. Now I can sub lambda into, I'm going to sub it into this one here, we'll call that equation 3. That's equation 2. That's equation 1. I'm going to sub it into equation 3. We've already used equation 2, so at the very end, I'm going to sub it into 1. Okay? So, 5 plus lambda, well, lambda is 1 plus 2 mu, so this becomes 5 plus 1 plus 2 mu is equal to 15 plus 4 mu. Now we've just got to solve, so this would be 6 plus 2 mu is equal to 15 plus 4 mu. So now if we solve this, I'm going to take 2 mu onto this side and then take the 15 across. So 6 minus 15, that gives me minus 9. And then 4 mu minus 2 mu gives me 2 mu. Okay. And now we've just got to solve for mu, because we've already got a value. Well, we haven't got a value for lambda, we've just got it in terms of mu. But once we've got that value for mu, we can get the value for lambda as well. So therefore, mu is going to be equal to minus 9 divided by 2. Okay, so minus 9 over 2. Now, because we've got mu, all we can do is sub this value here into here. So therefore, lambda is going to be equal to 1 plus 2 lots of minus 9 over 2. So therefore, lambda will be equal to 1 plus 2 lots of minus 9. So that'd be, it'd be 2 lots of minus 9 over 2, which will just cancel. They'll cancel there to give me minus 9. Sorry, so that'd be 1 minus 9. Okay, and 1 minus 9 just gives me minus 8. So, lambda equals minus 8, mu equals minus 9 over 2. All I've got to do now is sub it into equation 1, and then we can just show that there's a contradiction. So, sub into equation 1. So therefore, minus 3 plus 5 lots of lambda, well, lambda is minus 8, so 5 lots of minus 8 is equal to 10 plus 6 lots of mu plus 6 lots of minus 9 over 2. Okay, so that's minus 3 minus 40. 5 times minus 8 is minus 40. This is going to be equal to 10 plus 6 lots of minus 9 over 2, so that will become a 3. That will cancel, so 3 lots of minus 9 minus 27. Okay, minus 3 minus 40, minus 43. 10 minus 27, that will give me minus 17. Okay, and minus 43 is clearly not equal to minus 17. Okay, so therefore L1 and L2 do not meet, as there is a contradiction. A contradiction. And there we have it. So we've shown that L1 and L2 clearly don't meet. So let's have a look at the next question. So this is from exercise 9D. This is question 10, and again it's from the Corpio 1 book. So all these are from Corpio 1. So we've got another 2 lines here, which both have the Cartesian equations of these equations. And we've got to show that the point 3, 3, 7 lies on both L1 and L2. And then for part B, we have to find the size of the acute angle between the lines at A. So, to do this, for part A, all we're going to have to do is substitute this point in. If it lies on both of them, if we substitute it in, it'll clearly work. Okay, so if I substitute this in, so part A, well, I'm going to put 3, 3 and 7 in, so 3 minus 6 over minus 1 equal to 3 plus 3 over 2, and then I'll put 7 plus 2 over 3 over 3. What do I get? So 3 minus 6 minus 3 divided by minus 1, that's 3. 3 plus 3 is 6 divided by 2, that's 3. And then 7 plus 3 over 3 gives me 3. So therefore, 3, 3, 7 lies on L1. And then L2, so we're summing 3, 3, 7 in again, so that's 3 plus 5 over 2. That's going to be equal to 3 minus 15 over 2, minus 3, getting carried away, minus 3. And this is going to be equal to 7 minus 3 over 1. 3 plus 5 is 8 divided by 2, that's 4. 3 minus 15 minus 12 divided by minus 3, that gives us 4 again. And then 7 minus 3 is 4, divide that by 1, and you get 4 as well. So, therefore, 3, 3, 7 lies on L2. Okay. And then for part B, we have to find the size of the acute angle between the lines at A. So we just need the formula for this. That's going to be cos theta. It's going to be equal to the absolute of A divided with B, the scalar product, divided by the absolute of A, the modulus of A times the modulus of B. Okay. So A divided with B. So remember, for this, I have lost my original working for this, so we might have to do it by hand. Let's have a quick look if we can find it. Okay, so I've got all my original working. Makes life a bit easier for this one. So, for the acute angle at A, we just need to use this formula, but to save me having to write all my working out, we need to write what A and B are. So A will be equal. Now remember, we do the direction vector. We want to dot the direction vector, so it's going to be for A, which is L1, minus 1, 2, and 3. And then for B, again, the direction vector at B, don't forget, it's always the denominator, so it's going to be 2, minus 3, and 1. Okay? So, using this formula now, we can work this out dead easy. So this is going to be minus 1 times 2 plus 2 times minus 3 plus 3 times 1. All divided by. So the modulus of A, that's going to be minus 1 squared, which is 1, plus 2 squared, which is 4, plus 3 squared, which is 9. So 9 plus 4 is 13, plus 1, so that could be 14. Times that by the modulus of B. So that's going to be 2 squared, which is 4, plus 3 squared, which is 9, plus 1, so it's the exact same again. So that's going to be root 14. Okay. So, simplifying this now. Minus 1 times 2, that's minus 2. Plus minus 6, so that'll be minus 6. And then finally plus 3. Okay. And this is divided by root 14 times root 14, which is just 14. So that's minus 2 minus 6, which is minus 8, plus 3. So that'd be minus 5, but remember, we take the absolute, so that's going to be 5 over 14. And don't forget, we've got to do cos inverse this, because this is cos theta is equal to 5 over 14, so therefore, cos inverse 5 over 14, which is going to be equal to 69.1 degree. Okay, so there we have it. So that's just shown how we find the size of the acute angle between the lines at A. And then finally, the last question here. We've got the line with the vector equation r equals 5, 4 minus 1 plus lambda lots of 3 minus 1, 2. And it tells us that this is perpendicular to the line with vector equation r equals 0, 11, 3 plus mu minus 1 pp. So the first part just asks us to find the value of p. So for 2 marks, well, the key bit of information here is the fact that it's perpendicular to the line with the vector equation. So remember, if it's perpendicular, what that means is that if you use a scalar product, the dot product, so dot, the 2 direction vectors, so we call it b1 and b2, this has to be equal to 0. Okay, so all we've got to do is use a dot product for both direction vectors and then set it equal to 0 and just solve for p. So 3 times minus 1 plus minus 1 times p plus 2 lots of p, so 2 times p. This is all equal to 0. So if we solve this now, this is minus 3 minus p plus 2p. Okay, and that's equal to 0. So keep solving this now. This will be p is equal to 3. And there we go, we solved it. So we took the minus 3 across, and then minus p plus 2p is just p. So therefore p is equal to 3. So nice easy, part A there. And then part B, this time we're showing that the 2 lines do meet. And once we've shown that they meet, find the coordinates of the point of intersection. So again, we need to equate the corresponding part. So for my first line, if I call it L1, it'd be 5 plus 3 mu. And that would be equal to 0, so just nothing, plus minus mu. So if I write that down, 5 plus 3 lambda is equal to minus mu. Okay, again, keep going. So 4 minus lambda, that will be equal to 11. Now we know what p is, so that's going to be 11 plus 3 mu. Okay, you don't need to write, obviously, p lambda or p mu, sorry, because we know what p is, so that's 3. And then finally, minus 1 plus 2 lambda is equal to 3 plus 3 mu. So now we've equated the corresponding parts together, like we did last time. We've got to work out mu, we've got to work out lambda, and then substitute that into the final equation that we didn't work with. But in this case, because the lines do meet, what we should get is that they actually do equal each other. If they don't, then I've clearly done something wrong with my working during the question. So in this case here, the easiest one to work with is this one here, because it's already nearly in terms of mu. So again, divide through by minus 1, I get mu. It's going to be equal to minus 3 lambda minus 5. Okay, so because we've got mu, all I've got to do now is substitute this in. So if I sub it into, say, equation 2, so if I call that 1, this one's 2, and this one's 3. So if I sub this into 2 now, and then solve and get a value for lambda, we can then sub it into equation 3. Okay, so if I do that now, that'd be 4 minus lambda, which is going to be equal to 11 plus 3 lots of mu, which is minus 3 lambda minus 5. Simplify this now and solve. So 4 minus lambda is going to be equal to 11 minus 9 lambda minus 15. So let's start solving this. So 4 minus lambda is going to be equal to minus 4 minus 9 lambda. So that'd give me 8 lambda on this side, and that will be equal to minus 4 take 4 minus 8. So therefore, do it over here, lambda is going to be equal clearly to minus 8 divided by 8, so minus 1. And if we know lambda is minus 1, we can sub it now into this equation here for mu. So mu is equal to minus 3 times minus 1 minus 5. So minus 3 times minus 1 is 3 minus 5. You get mu is equal to minus 2. So now all we've actually got to do is substitute this into my equation 3, sorry, because we didn't use equation 3 yet. So if I sub that in, what we should get is that there is no contradiction. So if I do it up here now, so minus 1 plus 2 lambda, where lambda is minus 1, so 2 lots of minus 1, is equal to 3 plus 3 lots of mu. Oh, sorry. So my lambda is minus 8, so that's minus 8, so 2 lots of minus 8, plus, and then it's equal to 3 plus 3 lots of which one was it? Mu, where mu is equal to -2. So let's just check I've put everything in correct before we solve this. So it's -1 plus 2 lots of lambda, where lambda is -1. So yeah, it was correct. I can't read. I can't read at all. And that's equal to 3, which is plus, so it's equal to 3 plus 3 lots of -2. Okay, so I can't see any errors there. So let's just plug this in now to see what we get. So that's going to be -1 plus 2 lots of -1, that's -2. It's going to be equal to 3 plus 3 lots of -2, that's going to be -6. So -1 minus 2, it's -3. 3 minus 6, -3. Okay, perfect. So we've shown that they do meet. So we didn't get a contradiction, so therefore L1 and L2 meet. But we've not finished yet. We want the coordinates of the point of intersection. So all I'm going to quickly do now is clear all this. And what I need to do is take, say, my first line here, L1, and just substitute the lambda value in. So we know lambda's -1, so I'll quickly clear all this. So right, erase our link. So we know lambda is equal to -1. All I've got to do is sub that into this point here. So it's going to be 5. So it's obviously I'm just going to write it as a vector. So it's going to be 5 plus -1 times 3. Then I've got 4 plus -1 times -1. And then finally I'm going to have -1 plus -1 times 2. And once we simplify all these, we've got our coordinates. So 5 plus -1 times 3, so that's 5 plus -3, which should just be 5 minus 3, which is 2. So the first bit is 2. 4 plus -1 times -1, which is 1, so that's 4 plus 1, which is 5. And then finally, -1 plus bracket -1 times 2, so that's -1 minus 2, so I get -3. Okay, and there we have it. So that's the coordinates. So therefore, these are the coordinates of the point of intersection. And that's your final 4 marks. So there we have it. That's all the questions done. So I hope this proves to be helpful for anyone doing the Corp Pure. And hopefully it helps tremendously with your vectors. So if you're new around here, be sure to subscribe. I'm going to be doing a lot more further maths revision over the coming year.